Okay, a line that intersects a circle 2 times, which is different than yesterday. Yesterday we talked about a tangent. Remember, a tangent, if we're talking about a tangent, that means like we're getting on a story. It was kind of related, but then we get super off track. Macaulay, phone away, please. Okay, so tangent, how many times does a tangent intersect a circle? What did we say yesterday? 1 time, yeah. We looked yesterday, a tangent is a line that is tangent to a circle if it intersects it exactly 1 time. Okay, so tangent is a line. Yeah. A line that intersects a circle 1 time. And again, I'm going to capitalize that word 1 because that's our difference. It's 1 time or 2 times. So these are where I'm going to use our colored pencils today. You're going to pick 1 color for secant and 1 color for tangent. Because as we go, we do need to color code some of these lines. I'm going to use blue for secant. Okay, and I'm going to underline that word 2. And then I'm going to use green for tangent. If you're using other colors, that's fine, but you want to try and keep these consistent. So 1 color for secant, 1 color for tangent, and try to keep using those colors. Alright, so yesterday we did a tangent. When I draw that on the circle, what does it look like if a line only hits the circle exactly 1 time? Is it going through the circle? No, it would be touching the edge. So secant, I'm going to draw it with that color. I'm sorry, a tangent, so your tangent color. A tangent is always going to just hit it 1 time. So it's like it touches the edge and then it goes away. It just barely skims it. Okay, where a secant has to touch it 2 times. So in order to touch the circle 2 times, a secant is going to have to go through the circle. It enters the circle at 1 point, and then as the line continues, it goes through at the other point. Okay, if you want to label these, if you're not, especially if you're not color coding, I know most of you color code in this class, but with this blue one, if you want to put an S next to it so you know that that one's a secant. And this green one is a tangent, so if you want to put a T next to that one. Thank you. Alright, so here we go. We're going to start by color coding these ones. It says 2 secants. So as we look at our 2 secants, I'm using blue for secants. 1 secant would be A to C. It's going through the circle. And then I have another secant. What's my other secant line? Good, B to D. And today we're going to be really focusing on where they intersect. So where do they cross? So this time when they intersect, they're intersecting inside the circle. That point is inside. This is where I'm using that highlighter to show where they intersect. And that's at angle 1, which somebody said. Who said that? Somebody? A bunch of people? So if you want to highlight that 1 where they intersect, you can. It doesn't really show up super good on the camera. Okay, today is about measurements, and all of our measurements are going to look a little bit different. So this angle, is this angle at the center? Is angle 1 at the very middle of the circle? No, it's a little off. Is it inscribed? Is it on the edge of the circle? No. So to find that angle measure, we can use these arcs to find it. We just have to do it a little bit different. So we're going to label one arc that's across from the 1 x, and the other arc that's across on the opposite direction, y, and our formula to find that angle, measure of angle 1, equals, we do half of x plus y. So we add x and y together and then divide by 2. We average those arcs. So 1/2 of x plus y. So that's what our first thing is that we're going to do as we work through is we're going to be identifying these formulas. We only have one example today where we're going to use the formula, then you still have some practice. Because you guys know how to use formulas, we don't need to go through one of every example because that would be too many. All right, so in our next one, it says a secant intersects a tangent. So let's start talking about our secant. Which one of these lines is the secant? Is it the A to B or the line going by A? Good. Why is it A to B? Good. It goes through the circle. It intersects it 2 times. Good. Okay, so secant intersects tangent. So our tangent line is that one going next to the circle. It touches it exactly 1 time. Okay, and where do they intersect this time? Not inside. They circle at the point of tangency, which was a new word yesterday, or a new concept. The point of tangency, remember here, our point of tangency was point A. It's where it touches the circle. So another way to say point of tangency is to say it touches on the circle. Or you could say on the circle's edge, on the outside, not outside, don't say outside because it's on the circle, it's on the edge. All right, so if you want to highlight that A to show where it's intersecting. All right, and then across from angle 1, we're going to put X for that arc. And across from angle 2, we're going to put a Y. So there's a couple things about this one that we're going to write. This one has the most to write for. When it's on the point of tangency, this is an inscribed angle. And remember when we do inscribed angles, because it's on the circle itself, is that angle going to be double the size of X or half the size of X when I go from arc to angle? Is it going to get bigger or smaller? Smaller, so we do half. Good. So measure of angle 1 is going to be half of the arc across from it. What's across from angle 1? X. If you want to put it in parentheses, you could. And the measure of angle 2 would equal half of Y. But there's a couple hints here that we want to give ourselves when we're solving this problem, because they might not give us all the information. And there's 2 hints for this one. The first one is when we look at angle 1 and angle 2, angle 1 and angle 2 make that straight line that goes through A. So how many degrees is a straight line? What would they have to add up to? Oh boy. How many degrees is a line? 180. So we know that these 2 angles would add up to 180. So if I know one of them, I can figure out the other by subtracting from 180. Or you might use the idea of the arcs. If I add X and Y, X goes from A to B, Then y goes from B back to A, so it goes all the way around the circle. How many degrees would be all the way around the circle? 360. So as you solve this problem, you might need to use some of those hints to kind of figure out parts, because they might give you y and tell you to find angle 1. If they give you y, there's a couple things you could do. You could find angle 2, then know angle 2 and angle 1 add up to 180. Or you could find x, and then find 1. All right, you guys are crushing this? Next up, we have 2 secants this time. So whatever color you're using for your secants, we have 2 of them. Okay, so we have DB, or you could call it DA. This one's a ray. It starts at A and it goes through D. And our other ray starts at A and goes through E. This time they intersect where? Outside the circle. All right, so as we look at this, the measure of angle A, I didn't put a number there because it was too small to sneak in there. We're still going to be doing half. When it was inside the circle, we added the arcs together. When it's outside the circle, we're going to subtract the arcs. We're going to do x minus y. And the thing about subtracting the arcs is x has to be the larger arc, and y has to be the smaller arc. So in this case, which one would be the larger arc for A? Would it be DE or BC? Yeah, DE is, since it's further away, it's larger, so that's our x. And then our smaller arc would be BC. We're still looking at inside those 2 lines, in between those, how they intersect out. Okay, and that's really very similar to how the rest of this works. We just have different kinds of lines now. So those were 2 secants. Okay, the next one we have a secant and a tangent. So let's identify which one is the secant and which one is the tangent in this next one. A to D is what? Good, the secant. It goes through the circle, touches it twice, once at B, once at D. Where the tangent only touches the circle once. Where does this tangent touch it at? What's that point of tangency? Yep, C. Okay, but where those lines intersect is still outside of the circle. Okay, so again, to find that, it's the same formula. It's just, it looks different. These diagrams look a little bit different, but because they intersect on the outside, it ends up being the same formula. So measure of angle A equals 1/2 of x minus y. If you need to rewrite that's the larger arc and the smaller arc, you can. I'm not going to write that since it's up here. All right, so which one is my larger arc? Which one will be x? BC, BD, or DC? DC, good. We're only looking between those lines, so I'm not even looking at BD. That's not part of it. So the larger arc is D to C, and the smaller arc is BC. That's our Y. All right, last one is 2 tangents. And then we do have one example, so don't close your books. I know y'all are going to. Don't do it. Okay, 2 tangents. So we have AB and AC. And again, they intersect on the outside. So when you look at diagrams, a couple of things that you want to do is you want to see where do they intersect, and then what kind of lines are you working with. Is it 2 tangents, 2 secants, or one of each? So again, this one is the same concept. It'll be measure of angle A equals 1/2 of x minus y. So anytime we see a point on the outside, we're always going to do that x minus y. In this case, they're both starting at B and they're both ending at C. So is x going to be the major arc or the minor arc? Are we going to go the long way around or the short way? For the larger one? The long way. We're going to do major arc. So B to C, this is going to be our x here. And then our minor arc would be the B to C here. Now in this one specifically, not in the other ones, this one specifically, because they both start at B and they both end at C, it's going around the whole circle. So in this one, a hint, if they don't give you both x and y, that's okay, because you know x and y together make the whole circle. So what do x and y add up to? 360. All right, we have one example that we're going to do today, and then we have 2 more that we're going to add on tomorrow. It's a 2-day lesson today. All right, so I'm going to go to the next page. It's okay to go to the next page. Be chill. All right, so here's our examples. Example 1. If you need to write 10-6 continued on the top, you can. We're going to do 3 examples total, but we're just going to do 1 today, and then we'll do 2 tomorrow. Yes. There is homework today. All right, so we're going to draw a circle. That wasn't a very good one. That's okay. Wasn't great. Last year, look at the circle I made last year, you guys. Dang. That was a good circle. This circle, not so much. That's okay. Nah, I'm not going to try again. That's too much time. All right. This time we're going to have 2 secants going through this circle. So we're going to be crossing through. And we're going to try and make it so that it's a little off center. Doesn't look like it's exactly in the middle, but kind of close to the middle. All right, we know that this top arc here is 52 degrees. This arc is 96 degrees. And this arc is 98 degrees. Remember, these aren't the same because even though we have vertical angles, these arcs don't match the angles. They're not equal to those angles or exactly related. So it's okay that they're different. Okay, and then I'm going to put a number 4 here. And our goal is to find the measure of angle 4. All right, so are these intersecting inside the circle, outside the circle, or on the circle? Inside the circle. So when we look back at our work, we need to know the formula for, when we look back at our notes from from literally that we just did. I don't know, my brain can't work. The inside the circle formula is that we do half of x plus y. So I'm going to just write that down. Measure of angle 4 equals 1/2 of x plus y. So I need to decide which arcs are we going to use for x and y. So as I look at angle 4, I want to look across. So what would be across from angle 4? What arc? The 96 would be one of them. And what's the other one? It's going to be this one that we don't know. Okay. How can I find a missing arc in a circle? We know they all add up to 360. So we're going to take 360 minus 52 minus 98 minus 96. And our answer is 114. So we can label that 114 now. So it is a little bit multi-step. Sometimes you have to find those missing arcs. All right, so now the arcs that are across from angle 4, I have one that's 114 and one that's 96. Doesn't matter which one is x and which one is y. Can go in any order in this one. There's no bigger or smaller here. So I'm going to do 1/2 of 114 plus 96. Okay, if you're showing your work as you go, some people like to do that. Which part would we do first if we were doing it by hand? Good, the 114 plus 96. So it would be 1/2 of 210. Which remember to do half, you can just hit divide by 2. So divide by 2 is 105. So measure of angle 4 is 105 degrees. Now you could just type that all into Desmos all at once. That's what I would have done once we had these numbers. I would have skipped this second step here. Okay, because why work more when you can just put it in, right? Work smarter, not harder. Okay, and if you type in the whole thing, again, we get 105. Just make sure that you're using parentheses. If you're typing it into your actual phone calculator, and you type in 1/2 times 114 plus 96, it's not going to do it correctly. You have to use parentheses. Okay, that's going to give us a different answer. So, be careful on which calculator you use and what you're plugging in. So your goal today, first couple of questions you're going to be answering is about secants and tangents. The second question is you're going to be organizing these pictures in the formulas together. And then there's a couple questions where you're doing this. So you have to decide which formula to use and plug in the right numbers.